Good morning, my dear student. I'm Rakesh Shove from Sunbeam Sun City. Jai Hind you all. Morning, बच्चों. Today in the morning I thought about to upload the topic of optical length because I told you that I will show you the magnifying power while discussing with the compound microscope how to find the answer in terms of optical length or tube length. And I told you yesterday in my all video lectures that there is a difference in the separation between the two lengths, and when we talk about the optical length, the separation is called mechanical length or mechanical length of a tube. Whereas this is the optical length, which is a difference between the second principal focus of the objective and the first principal focus of the eyepiece. I will draw the diagram once again. Let us say take the same diagram for LDDV. I am doing for LDDV, you will all go for infinity. Am I clear? You will show me for infinity by doing the same topic. Okay. Now let us draw the diagram. Here is the convex lens objective. This is the optical center. Here say I have taken the principal axis. Draw the diagram fast so that we can go for the things. This is the say object is placed very close to the principal focus of objective. As I said yesterday in my video lecture, try to understand when I say very close, it means it is, if I take that distance from F4, no issues. That is a way of say very close. So this is object AB and this is placed very close to focal plane. Here there is the ray which is parallel to the principal axis. You all know, sir, this will be passed to the principal focus. But before that, there should not be any problem. Let us draw the ray passing through the optical center. So here is the optical center, here the ray passing, and this will pass like this without any bending. It will pass straight. So say here it is passing, my dear. And this is what the refraction through the optical center, say objective O. Am I clear? And the another ray will pass through the principal focus. Say this ray is passing through the principal focus from here. Say, my dear, I have drawn this two ray. Okay, and they are intersecting. They are meeting at this point. You can see. And here, this is the, my dear, I am sure this is the second principal focus of this objective lens. This is objective lens, and it is the second principal focus, and this is the first principal focus of the objective lens, and the object is kept close to the first principal focus of the objective lens or close to the principal focus. And what is the meaning of close? So obviously it will be close means that if you wanted to take a distance from here, there is no issue that I can take a distance of this object from F also. And earlier situation was this, that the object was actually at the least distance of distinct vision, my dear, if you all remember. Am I clear? And the object is actually at least distance of distinct vision and converging an angle of alpha. It's subtending angle of alpha at the normal point. I am keeping the object and I am observing it at the near point. I am kept the object and I am observing now with a normal eye. Am I clear, my dear? This is the situation. And when I introduce the lens, this is earlier situation. Now when I introduce the lens, my dear, try to understand what is happening here. As soon as I introduce the lens, the distance which was here of the object from the eye, say here is the eye, at the least distance of distinct vision, and the object is somewhere here, say. As soon as I introduce the lens, what happened, my dear? The distance of the object decreases towards the eye. As soon as I introduce the lens, earlier the lens eye and the distance of the object is somewhere capital D, you can see. But what is the use of this objective lens? Anybody can ask you, my dear. So you should aware about, sir, as soon as I introduce this objective lens, you know what happens, sir? Sir, distance of the object. Am I clear? Because you can see the object comes to the focal point of this objective lens, close to the focal point of objective lens. So it means the distance of the object from eye. Distance of the object from eye, my dear, from this case and after introduction of the lens, the distance of the object from the eye decreases. And as soon as this distance decreases, You can see, you can feel बच्चे, as soon as the distance decreases, no doubt the angular magnification will increase. कोई चीज नजदीक आ जाएगा तो उसका एंगुलर मैग्निफिकेशन ऑफ कोर्स बढ़ जाएगा. So this concept को बच्चों समझो, and here is the objective play a great role. The introduction of this lens caused, NCRT has written, is that earlier the distance was, say, the height of this object is h. So earlier the distance was tan alpha is nothing but h by d. But now as soon as I introduce the lens, objective lens, my dear, this tan alpha will become h by uo. If I see, this is taken as, say, uo. But believe me, my dear, this uo is less than d. This is after introducing objective lens. So the distance of UO will be less than d, and the distance towards the eye for this object will decreases as compared to this case. And my dear, angular magnification at the eye increase. Thus, this lens increase its angular magnification when it is viewed through the eye, because it caused the introduction of lens caused the decreasing of distance, because I brought this object towards the focal point of this objective, or near to the focal point of the objective lens. Try to understand. This is a beautiful concept, my dear. So ये objective कोई भी पूछे, what is the use of introduction of this? Immediately say, sir, distance which you are observing through the normal eye, now that distance is decreases, and the distance between the eye and objective decreases, so it causes increase in angular magnification. So this way, this objective increase the angular magnification, this lens in the eye. And that, my dear, I will show you here. That is important for calculation of optical length. Here is, my dear, the image. You all know I am doing the diagram for 3-4 times. And here this is the first image, B dash, A dash. So now I draw the. So I am rubbing this, bachche. This is what I wanted to tell you all. Okay, please take care, because this is the important concept. What this objective lens is doing. So you should know that objective lens, चौबे sir, जैसे ही objective lens introduce किया, distance of the object from eye decreases, and no doubt, sir, angular magnification in the eye will increase. So this objective lens increase the angular magnification in the eye. Now, next step, what I am doing, bachche, here you all know I can draw the another lens. With the optical center, and here, bachche, I can stop this way. Here they are falling on the optic axis, and now they will go here. I hope it is clear. And one ray will pass through the optical center, passing through this point also. Like this. And please ask this line, this ray to come down at the back at the least distance of distinct vision, because this will produce the image at least distance. Suppose this is my, I showed in the earlier drawing this object यहाँ पर LDD. अब वो आगे आ गया है, and that object is brought to the focal point of the objective. First principal focus of the objective है, close to that मैंने object को लाया, जिसके वजह से सर उसका distance कम हुआ by introducing this lens in the eye. And जैसे distance from the eye कम हुआ सर, angular magnification बढ़ गया. This is written in NCRT also कि ये क्या करता है, लेंस क्या कॉज करता है. सर डिस्टेंस जो पहले था D उसको कम करता है, और जैसे ही सर आँख से उसका डिस्टेंस कम हो जाता है ना, D से U नॉट कम है, और जैसे ये कम हुआ बच्चे, एंगुलर मैग्निफिकेशन बढ़ जाएगा, आप देख सकते हैं. सो प्लीज कंसेप्ट को समझो बच्चे. और यहाँ पर फिर मैंने इसको भी एक रे विल बी गो पैरेलल टू द प्रिंसिपल एक्सिस लाइक दिस. This is the third time I am drawing the diagram, and of course obviously this ray which is going parallel to the principal axis will pass to this principal focus, you can see, and here I can mark the second principal focus of the eyepiece, and here is the, I'll tell you this about. Now I will make these all rays to meet at one point, my dear. I will see to this that all the rays should meet at one point. This ray I need to withdraw. I will make all the ray to coincide at one point. This ray is very important, the last one, that makes us to understand the coincidence of this. So here is the, I am drawing the diagram, my dear. This is the, I hope you all understood, this is the diagram for the, if you remember, my dear, this is the diagram for your least distance of distinct vision. Okay. And this is the optical center, and here I will mark E, and this ray will be go like this. Okay. Now my dear, all these rays when I am talking and they are meeting and they are forming here the second image B dash A double dash at a distance of capital D, you all know. Now here, my dear, the image is formed. You can see that this distance is nothing but obviously VO, because it is formed by the objective lens. And I have told in my previous topic कि obviously now, जैसे मैंने यहाँ पे capital D पे था objective lens introduce किया, and I brought the object from capital D to the near to the focal point of the objective. है ना, close to the focal point of the objective, you can see. Similarly, my dear, here as soon as I got the image A dash B dash, जैसे ये image मिल गया मुझे A dash B dash, real inverted image, first image is real inverted, the final image is obviously with respect to first image is virtually racked, but with respect to the real object, the initial object, the actual object, this image is real inverted. So my dear, this first image जो मुझे मिला, what I am going to do, I will adjust the eyepiece. This is my eyepiece. Right? I will adjust the eyepiece, my dear, and I will bring this image within the focal length of first focal point of the eyepiece. Within the first focal point of the eyepiece, my dear, or close to the, जैसे इसको लाया मैंने object को, ऐसे ही this eyepiece is so adjusted, sir, that this image, the first final image, the first image A dash B dash is lie within the focal plane of the objective, my dear. Is lie within the focal plane of the objective, believe me, and this will be possible. So this eyepiece is so adjusted that this image A dash B dash, the first image, not final image is this, the first image A dash B dash, which is real inverted, lie within the focal length or focal point of the eyepiece, or close to the focal point of eyepiece. I have given all this idea in my previous video for LDD, and for infinity, so it will be lie on the focal point of the eyepiece. It will lie on the focal point of eyepiece, then only the image will form at infinity. Okay. And my dear, you all know that, so this is the angle subtended by the image, final image. And who subtend this angle? Sir, eyepiece. It is because of the eyepiece. and eyepiece act as a simple microscope. So I can say this is the angle subtended by the final image when it is viewed through eyepiece, or when eyepiece act as a simple microscope. When eyepiece act as a simple microscope. And what I did, my dear, I adjusted the eyepiece and I brought this image, the first image A dash B dash, within the focal length of eyepiece, that is near the focal point of the eyepiece. I hope it is clear with you. So now, my dear, here please take care. And now you all know that the last 2-3 important points, you all know that the distance between the objective and eyepiece, this is your mechanical length of tube. And here, my dear, this is optical length of tube. Or tube length denoted by L, and I treated this as L dash. So what is optical length from my diagram? Sir, optical length is nothing but a difference between, a distance between the second principal focus of the objective lens. Second principal focus, because this is the first principal focus. So this is first principal focus of objective, this is second principal focus of objective, this is first principal focus of eyepiece. Of course, this is beside first. First principal focus of eyepiece and second principal focus of eyepiece. So now, sir, by looking the diagram, what is optical length? Sir, it is a difference or distance between, my dear, the second principal focus of objective lens and first principal focus of eyepiece lens. Or first principal point of focal point of principal focal point of eyepiece lens. Clear? Please. So my dear, first I will write the definition of optical length. So what is optical length, everybody? Optical length or tube length is distance between second principal focal point, second principal focal point of objective lens and first principal focal point of eyepiece lens. Please, you can see. And now, my dear, I will tell you what I supposed to do. As soon as, my dear, I will take this concept, you all can see that what is happening here. If I took this distance, everybody look at it. If I took this distance as an optical length, because definition says this is the optical length. So now, my dear, I think the optical length is that length which carry the magnification. See, the field of this, the area of this optical length, थोड़ा सा लॉजिक रखो. द एरिया ऑफ ऑप्टिकल लेंथ सर क्या करता है, क्या कवर कर रहा है सर? मेरे ख्याल से ऑब्जेक्टिव का मैग्निफिकेशन, ऑब्जेक्टिव लेंस जो मैग्निफिकेशन कर रहा है. लॉजिक सर, ऑप्टिकल लेंथ क्या है? और ये सब डायग्राम है सर, यहां तक यू कैन सी डायग्राम. सो सर, इट मीन्स ऑप्टिकल लेंथ लॉजिकली सर अगर सोचो तो इट इज वर्किंग, it is giving the concept for magnification done by the objective lens. Magnification done by the objective lens, that is MO. MO का आइडिया दे रहा है सर. इसका लॉजिकली देखो ना यार, ये इतना डिस्टेंस इज ऑप्टिकल लेंथ, मतलब समवेयर इट इज गिविंग एन कंसेप्ट फॉर हाउ दिस ऑब्जेक्टिव लेंस मैग्निफाई. MO, मैग्निफिकेशन ऑफ बाय द ऑब्जेक्टिव लेंस देता है. प्लीज ये बात ध्यान. So now, my dear, देखो मैं इस बात को कैसे प्रूव करता हूँ. फॉर एग्जाम्पल here it is alpha because here it is object and say here it is the image forming, and I draw there here as beta naught. This is alpha while object. This is not with the normal eye. नॉर्मल ह्यूमन आई से नहीं हुआ है. जब ऑब्जेक्टिव लेंस लाया तो एंगल कितना था बाय द ऑब्जेक्ट, बिकॉज आई ब्रॉट इट क्लोज आफ्टर इंट्रोडक्शन. सो नाउ द एंगल इज व्हाट ऑफ द ऑब्जेक्ट. आई होप इट इज क्लियर. ओके, सो नाउ आई विल टेल यू अबाउट इट, that how it is happening. So I draw the object angle, that when I brought the lens, then what was the distance of the object, and that caused an angle. This is, my dear, angle subtended when I observe through the eye, not after the introduction of lens, but this is our angle of the object subtended to the lens. Am I clear? So this is the angle, and no doubt this same angle will be subtended at the eye, because I told you all I am keeping the eye. Now here, my dear, this is the image formed by this lens of this object, and here you can say, sir, this is the angle subtended by the in the eye. In the eye, again यहाँ से भी मैं आँख रख के देखूँगा image को. So this is the angle subtended by the image, my dear, this first image at the eye. And who drawn this first image, sir? Objective lens. So I have taken this as beta naught. जैसे यहाँ फाइनल इमेज को बीटा लिया था और इसको अल्फा लिया था, वैसे मेरे बच्चे ऑब्जेक्टिव लेंस को लेके जरा कंसेप्ट देखो और ऑप्टिकल लेंथ के कंसेप्ट को समझो. ये लॉजिकल है कि सर ऑप्टिकल लेंथ इज कवरिंग this magnification of the objective lens. Concept of optical length lie with the magnification which is done by this objective lens when the object is brought closer. बच्चे प्लीज मेन कंसेप्ट हो, ये ऑब्जेक्ट जैसे ब्रॉट क्लोज किया, ऑब्जेक्टिव लेंस ने मैग्निफिकेशन कर दिया बच्चे, उसका एंगुलर मैग्निफिकेशन कर दिया, और वो एंगुलर मैग्निफिकेशन वी विल कैलकुलेट विद द टर्म्स ऑफ द ऑप्टिकल लेंथ. बच्चे यू कैन सी. ओके, सो आई विल डू इट एंड आई विल शो यू दैट हाउ दिस इज द आंसर. As I told you about optical length, it's concepts when you talk about, oh God, sir, this logically, please, I told you in my video, so once again I am revising this. The optical length is logically, sir, it is in the region of, when you see logically, when you see this lie in the region, by according to definition, that between the second principal focus of objective and first principal focus of eyepiece. Sir, it is carrying the region where objective lens magnify the object. This is the region, my dear, where this is the first image you all can see, which is nothing but a magnification, the first magnification of this object by this objective lens. Remember this. और ये magnification क्यों हुआ है sir? That also I explained. Sir, earlier with the normal human eye, you looking at a distance of capital D. Right, so you are looking at a distance of capital D, but now as soon as I introduce the lens, my dear, this object is come closer, and it come closer to the principal focus of objective from least distance. So what happened? Of course, पहले यहाँ तक था, फिर अब ऐसे आया तो आँख से भी distance कम हो गया. So as soon as the distance from the eye decreases, my dear, because of this introduction of objective lens that caused to decrease the distance of the object towards eye, my dear, of course, sir, the angular magnification will increase. So this is what the objective lens is increasing, that magnification, my dear. That is the concept related to optical length. Then how much is the magnification done by the objective lens? How much is the magnification done by the objective lens? This beta O. I have in previous video I said beta naught. That's sorry. This is beta O. That is the image which is subtended by this objective lens, my dear, A dash B dash. This image is formed by this objective lens. How much that image is magnified? How much this image is magnified, my dear? By keeping the object, by bringing the object close to the lens, my dear. And if it is close to lens, it will come close to eye. So how much that will magnify? That is the concept related to optical length. That region, that's the concepts of optical length. So optical length carrying, please bache, optical length, sir, it carry a concepts of magnification which is done by the objective lens. By the objective lens, this magnification is done by the objective lens, my dear, beta O of this image. You can see for this object, my dear. And why? How this magnification, sir? Of course, it will bring close to the lens, And of course, when I weave through eye, the distance is decreases, angular magnification will increase. So ये कितना से ये लेंस ने, ऑब्जेक्टिव लेंस ने मैग्निफिकेशन, एंगुलर मैग्निफिकेशन कितने से बढ़ाया जब ये डिस्टेंस मैंने और लाया आगे इसके क्लोज टू द फोकल पॉइंट ऑफ ऑब्जेक्टिव पे जब मैं लाया तो ये मैग्निफिकेशन कितने से बढ़ रहा है. दैट इज द कंसेप्ट रिलेटेड टू ऑप्टिकल लेंस से कंसेप्ट से. दैट इज द ऑप्टिकल लेंथ रिलेटेड कंसेप्ट. ये ऑब्जेक्टिव ने कितना मैग्नीफाई किया मेरे बच्चे ये ऑब्जेक्ट को व्हेन आई ब्रिंग इट क्लोजर टू दैट objectives. So please take care. This is what I wanted to say. But here in the diagram, I think this is beta O. Can I draw beta O here also? This is also beta O. This is also beta O. And if I see here, I can draw here as a line. You can see here. Here I can put a M was word, say it is following M. So I can see this and this become same H, and I am getting these triangles. So now let us see and let's start how it is related to the how it gives this idea about beta O. That is the magnification done by the objective lens. I'll repeat, beta O magnification done by the objective lens. Nothing doing with eyepiece, my dear. Done by objective lens when the object is brought closer. When object is brought closer to the eye. Of course the object is brought closer, my dear, and closer कहाँ पर? It close to the focal point of objective. So distance कम हुआ, angular magnification बढ़ा. सर कितने से बढ़ा? That calculation will be done, and that will comes in terms of optical length. So angular magnification done by the objective, my dear, in eye will be calculated in terms of the optical length. Please, the magnification which is done by the objective lens in eye is in terms of optical length. So now, my dear, here I can calculate here from figure in triangle. Say I have taken a triangle in triangle MOF. If I find, my dear, beta O, so beta O is 10 beta O, and that will be nothing but, you can see it is nothing but here it is H, because this and this is same, so it is H, and here you can see FO, yes, FO. So this is H by FO. Am I clear? H by FO. Put this as equation number 1. Similarly, my dear, in triangle, you can see image is forming A dash B dash FO. A dash B dash FO. Here is also a beta O, and that beta O is written as 10 beta O. That is magnification done by objective lens when the object is brought closer and to the focal point of objective. So distance to the eye also decreases, my dear. This is written clearly in NCERT. Objective lens का काम क्या है सर? यही है. क्या काम है? प्लीज, मैंने अपने प्रीवियस वीडियो में ही बताया सर. ऑब्जेक्टिव लेंस जैसे इंट्रोड्यूस करते हैं, ऑब्जेक्ट का डिस्टेंस टुवर्ड्स आई डिक्रीजेस and it caused to increase the angular magnification, and that is the concept with related to optical length. ये कितने से angular magnification बढ़ा? That is in terms of optical length or tube length. So now, my dear, this angular magnification in terms of tube length by objective lens. So this is 10 beta O is equal to, now here in this diagram, in this triangle, Chobe sir, this is, I hope, H dash divided by L. H dash divided by L. Oh sir, here it is B dash here, and L is actually between FO and FE. L is between FO and FE. Second principal focus objective and first principal focus eyepiece, whereas image is at B dash. Still this much is the gap and you are taking that as L. My dear, I hope I have written, since the image, if you all know, A dash B dash is obtained close to the principal focal point of eyepiece, if you remember, I told you I adjusted the eyepiece, and as soon as this image is obtained by this objective lens, what I did, this will act as the object for this, and I adjusted the eyepiece, my dear, such that this image which is obtained by this objective is lie within the focal length of eyepiece or close to the focal length of eyepiece. ऐसे adjust किया. तो अगर सर ये image is close to focal length of eyepiece, what's wrong? I take a distance from B dash or I take a distance from FE because they are very close. B dash is very close to FE. Because I said whenever we use a statement close, we say then that both the points are at the same point. Both are at same point. Close word का मतलब ही physics में that they are at the one point consideration. So here B dash and FE are so close, my dear, because I have adjusted eyepiece and I brought this image A dash B dash close to the focal point of this eyepiece. Close to focal point of eyepiece, they are very close to each other. So distance measured from B dash to FO or distance between FO and FE, which is L, can be taken considered. In infinity case, so it is very easy, bache. In infinity, when the image is obtained at infinity by eyepiece, of course this image which is obtained by objective will be at the focal point of eyepiece. Focal point of eyepiece पे ये image आ जाएगा. अभी तो close है. Infinity case में तो this will be on the focal point of eyepiece. And there to no need to say what is happening. But here you have to state that this is close, sir. So when it is close, so either a distance between F dash and FE and B dash is nothing, sir. They are very close to each other. So distance measured from B dash to FO or distance measured from FE to FO is same. And that is it. Super. So now my dear, this is, I will put this as equation number 2. So on from 1 and 2, look at it what I am getting. This is also tan beta O and this is also tan beta O. So this is H by FO is equal to H dash by L. Therefore, my dear, this will give me H dash by H is equal to L by FO. Oh, super. H dash by H is equal to L by FO. But you all know, my dear, H dash by H, that is size of image upon size of object. For convex lens, my dear, it is nothing but VO upon UO, that is objective, that image distance by objective divided by object distance from objective. Everybody know. It is VO, of course this is VO divided by UO is nothing but H dash divided by H, because ABO, triangle ABO and triangle A dash B dash O are similar triangle. ABO and A dash B dash O, A dash B dash O are similar triangle. So of course there is corresponding ratios. H dash upon H, H dash upon H is equal to VO upon UO. And for convex lens, my dear, you all know the lenses, the magnification is positive only, that is VO by UO only. So it is VO by UO, you all clear about it. Now here, my dear, this is put it as equation number 4. So from 3 and 4, we get 3 and 4, VO, H dash upon H is VO upon UO, na? So this is nothing but, my dear, VO upon UO is equal to L by FO. VO upon UO is L by FO. Now I got VO upon UO is L by FO. So now, my dear, magnification formula, here point number 1, magnification formula in terms of optical length for LDDV. So M at LDDV, my dear, is answer is VO upon UO. This is 1 plus D by FE. This is the formula, magnification formula in terms of optical length. So first I have written M at LDDV is VO upon UO is 1 plus D by FE. This is the formula we obtained. Now sir, you said VO upon UO by optical length concept. VO upon UO is L by FO. And please here also don't worry about the any minus signs, or this will be minus, or H dash is minus and this that. My dear, let me tell you, I am writing 10 concept. You all know it is length of opposite side divided by length of adjacent. In previous all videos I told you, magnification is always in positive, angle magnification. It is always in positive. So whenever any negative word is there, please put a mod. Because final answer you have to write the angular magnification, the calculation will be in positive, answer will be in positive, angle magnification. Am I clear? So my dear, for that reason, even if I getting UO in topic, UO is negative, suppose. Here I got UO ka value as minus. I told you in my previous video, minus 5 centimeter. Okay. That understood, it should be minus sir. Answer जब calculate करेंगे तो minus आना चाहिए. But while substituting in magnification, here it is mod. Even FE is in the mod because FE is the focal length of convex lens are always in positive. So now my dear, but remember this cases because sometime you all are thinking, अरे minus डालूँ क्या, अरे plus करूँ क्या? My dear, you are calculating ultimately a magnification and name is what? Angular magnification. So answer will be in positive. So all this negative thing, let the answer is coming in negative. UO, FE, जो भी answers है, sorry UO answer है, UE answer है, UO, UE, all these are coming negative because here it is UE actually. Here it is UE actually. And here you can see the mechanical length of the tube is nothing but L dash and that is nothing but VO plus UE. But optical length is nothing but, my dear, it is a difference between FO and FE. Second principal focus of objective and first principal focus of eyepiece. Try to understand mechanical length का क्या formula है और optical length कैसे मिल रहा है. So now my dear, here VO upon UO is directly written as this VO upon UO is L by FO and this is 1 plus D by FE. That is the magnification formula of LDDV. So VO by UO will replace. So now my dear, as I said, VO by UO is nothing but L by FO. So this is L by FO into 1 plus D by FE. This VO by UO divide is given by L by FO conversion. That's all. Similarly, my dear, the magnifying power at infinity, my dear, is VO by UO into D by FE. Yesterday we have done. So here VO by UO again, in terms of optical length, I will write it as L by FO. So VO by UO again written as L by FO. So it is L by FO into D by FE is also can be answered. So this is all about, my dear, this part to be considered in terms of optical length, and this is in terms of VO and UO. This is also a magnification for objective, and this is also a magnification done by the objective, my dear. L by FO is what? L by FO, this answer is nothing but the magnification done by the objective lens. That is nothing but MO. So how much this objective lens magnified, my dear, I have written in terms of optical length. Take care of that. That is important concept which I keep saying, that this optical length is actually, sir, is related to a concept of the magnification, how much the magnification done by the objective lens. And we all know magnification done by objective lens is generally VO by UO. But then today I thought that you should know in terms of optical length, it can be written as L by FO also, which you can see by geometry. That's the point. So remember, my dear, so whenever the numerical is based on all these topics, whenever these numericals are given, my dear, believe me, the numericals are based either with VO, UO, 1 plus DFE when VO and UO all are given in data. Sometimes they are given the tube length or optical length in data, my dear. Then you have to use this formula. And remember, they have given sometimes the separation between the two lenses. then don't say that as a optical length or tube length. Don't go to that point. The separation is calculated by diagram, sir. This is a diagram for LTDV. No doubt the separation between here it is VO and here it is UE. So when I add VO and UE, I get the separation between the two lenses. So in terms of LTDV, it is VO plus UE, whereas in terms of infinity, sir, यहाँ पे ये FE पे आ जाता है. So it is VO plus FE in terms of infinity, the separation between two lenses. So this is all about from my side, बच्चों. Jai Hind you all, and thank you all. God bless you. See the videos carefully. Thank you very much.